So we'll take some basic numericals on the stresses in the case of power screw. We are given here a power screw of 32 mm nominal diameter, 5 mm pitch. The actual load is 12 kilonewton. The permissible thread bearing pressure is equal to 6 megapascal. That is the bearing stress you can take equal to 6 megapascal. Considering the bearing action between the thread in engagement, what is the number of thread in the engagement with the screw? If we develop the n number of threads in contact, then we get the area, and this top area will be the resisting area for the force F, and it's called as bearing area. And if you unwrap here one thread, then we get a length equal to pi into dc, and we have number of threads equal to n. So total length will be equal to pi dc into n. Height of the thread is p by 2, width is also equal to p by 2. In that case, we have projected area will be equal to pi into dc into n multiplied by width, which is equal to p by 2. So force upon area will be the bearing stress. So bearing stress is given as force upon projected area, and the projected area is same as pi into dc into n number of thread multiplied by pitch. So we need to calculate here the value of core diameter first. We have nominal diameter is given as 32, so we have DO is equal to 32 mm, pitch is given as 5 mm, the axial load is given as 12 kilonewton is 12,000, and we have given the bearing pressure equal to P bearing equal to 6 megapascal. So the core diameter will be equal to DC is same as equal to DO minus pitch, that equal to 32 minus 5 is equal to 27 mm, and we know the value of bearing pressure, that equal to 6 megapascal. So we have 6 megapascal is equal to 2 times of F. F is equal to 12,000 divided by pi. We have core diameter equal to 27 into number of threads n. We have to find out the value of pitch P is equal to 5 mm. Solve this, you will get the number of threads. You have to use the integer value, that will be equal to 9.43, or we can say approximately 10 threads are engaged. A force F is to be transmitted through a square thread power screw into a nut. If T is the height of the nut, we have used the symbol H for the height of the nut. Here he has used the symbol equal to T. And D is the minor diameter, then which of the following is the average shear stress? 2F by pi dt, F by pi dt, F by 2 pi dt, or 4F by pi dt. In theory, we have developed the expression for the average shear stress. We have length at the root will be equal to pi dc into n, and the height will be equal to p by 2. The load F is parallel to the given area, and the given area is same as pi into dc into n multiplied by p by 2. So tau average will be same as force upon the area, so that will be equal to 2f divided by pi into dc into n into p. This value of n into p is same as equal to the height of the nut, that equal to t, and dc we have to represent by the minor diameter equal to d. So in this case, we have tau average will be equal to 2 times of f divided by pi. The minor diameter will represent by t, and t represents here the height of the nut. So our expression for average shear stress is 2 times of f divided by pi dt. 2 times of f upon pi dt, choice A is correct choice. In a testing machine, a square thread screw has to withstand a tensile load of 550 kilonewton. The nominal diameter DO is equal to 100 mm and pitch equal to 20 mm. The average shear stress is given as 25 Newton per mm square. The height of the nut we have to find out. This time the failure is due to the shear stress. So we have given here the value of tau average. Tau average is same as equal to 25 is megapascal. Nominal diameter D0 is same as equal to 100 mm. Pitch is given equal to 20 mm. Therefore, we have core diameter, that is DC equal to DO minus pitch, which is equal to 100 minus 20 is equal to 80 mm. The area resisting will be equal to pi into DC into N into pitch divided by 2. And we have given the value of force is equal to 550 kilonewton. 550 kilonewton. We know the average shear stress is given as force divided by area resisting the shear. So at root we have pi into DC into N into P, and 2 will shift in numerator. We have to calculate here the height of the nut. N into P is same as the height of nut, that is product of number of thread in engagement and multiplied by pitch will be same as equal to height. So we have tau average is same as equal to 2 times of F divided by pi into DC into H. Tau average is given as 25 megapascal is equal to 2 times of F. F is given as 550 10 to the power 3 divided by pi. We have core diameter, that is the root diameter, equal to 80 multiplied by height h. So we are comfortable to calculate here the height h. So in this case we will get the height of nut approximately equal to 175 mm. A machine vise has a single start square thread of 22 mm nominal diameter and 5 mm pitch. The maximum clamping force F is equal to 2870 Newton. The machinist can comfortably exert a force of 125 Newton on the handle of the mean radius equal to 150. External force applied on the handle is P is 125 and the length of handle LH is 150. So we can calculate here the external torque applied. So force acting and the torque acting on the screw body is known. So the screw body has a diameter equal to DC, which is DO minus P, is subjected to external load equal to F, which is same as equal to W, and that value is given as 2870 Newton. External torque is also known is P multiplied by L. Due to the force F, the compressive stress is developed on the circular cross section of a screw body is pi by 4 into core diameter square multiplied by sigma. This value of sigma will be compressive in nature. And due to torsion, the shear stress is produced is pi by 16 into core diameter cube multiplied by shear stress tau. And these two stresses will act on the body. In that case, we have to calculate the principal stresses. The principal stress we can calculate as sigma max and sigma minimum. For this one, we have relation is sigma x plus sigma y by 2 plus minus under root of sigma x minus sigma y by 2 whole square plus tau xy square. So initially you have to calculate here what is the stress acting along the x direction. So there is no stress acting along the x direction. This one is a compressive stress whose magnitude we take as a negative is the value of sigma y, and tau xy is same as equal to tau. The nominal diameter is same as equal to DO, and this nominal diameter is given as 22 mm. Pitch P, for single start pitch is same as equal to lead is given as 5 mm. The maximum clamping force F is given as 2870 Newton. Machinist can apply a force P is equal to 125 Newton on the length of handle LH is equal to 150 mm. So P multiplied by LH will be same as the torque required to raise the load is equal to P multiplied by LH. That is, we have 125 multiplied by 150. This is Newton mm is 18750 Newton mm. Hence we can calculate here the value of sigma c, that is the compressive stress developed is sigma c is equal to sigma y. You have to take this value as a negative value because it's a compressive nature is force upon pi by 4. So 4 will shift in numerator, pi by 4 dc square. So we have minus 4 times. We have clamping force is equal to 2870 divided by pi into core diameter. Now we require here core diameter. So core diameter DC is same as D0 minus pitch, that equal to 22 minus 5 is equal to 17 mm. So we have pi into 17 square is minus 12.64 will be megapascal. And the torque required to raise the load TR is given as pi into core diameter cube of it multiplied by tau, so divided by 16. In this case we have TR is 18750 equal to pi divided by 16 into DC cube. DC cube is same as equal to 17 cube multiplied by tau. So we have tau xy is same as equal to tau is equal to 6.79 is megapascal. So just substitute in this formula and we can calculate the principal stress. So we have value of sigma x is equal to 0 plus we have sigma y is negative 12.64 divided by 2 plus minus under root of sigma x equal to 0. Minus and minus become plus. We have 12.64 divided by 2. We have square of it plus we have tau xy which is 6.79. Again you have to make a square of it. Considering the positive sign, we will get one value of the stress that we called as sigma maximum will be equal to 2.953. This value will be in megapascal. And consider the negative sign, we will get sigma minimum will be equal to minus 15.6 megapascal. A milling machine slide of weight equal to 20 kilonewton is raised, that is the value of F is given or W is given, by a single start square thread screw of DO is equal to 50 mm and pitch is equal to 7 mm at a maximum speed of 600 mm per minute. The coefficient of friction at the thread, that is the value of mu, is given as 0.12. Number of threads in the nut if allowable bearing pressure is 12 megapascal, that you have to find out. Value of N you have to find out, and the principal stresses in the screw you have to calculate. The screw body is subjected by the load F, which is same as equal to pi by 4 dc square into sigma c. Sigma c is the compressive stress produced, and due to the friction between the thread and the screw we have TR. So this one is only the contribution due to screw, not by collar, is equal to pi by 16 into dc cube multiplied by tau. dc we required here, dm we required, number of threads you have to find out, and the principal stresses you have to find out. Principal stress you can calculate as sigma x plus sigma y by 2. Sigma x will be 0, sigma y will be compressive stress is negative value, plus minus under root of sigma x minus sigma y by 2 whole square plus tau xy square. So in this case we have force F is same as equal to W is equal to 20 kilo Newton. Outside diameter DO is equal to 50 mm. Pitch is given as 7 mm. We require both DM as well as DC, so we have DM will be equal to DO minus pitch divided by 2, that is we have 50 minus 7 divided by 2. 50 minus 3.5 is 46.5 mm, and we have core diameter DC is DO minus pitch is equal to 50 minus 7 equal to 43 mm. Coefficient of friction mu is given equal to 0.12, which is same as equal to tan of phi. So we get a friction angle phi is equal to 6.84. And to calculate the lead angle here, we have tan of lambda is L. L is same as pitch per single start divided by pi multiplied by dm. We have lead is equal to 7 divided by pi, and we have mean diameter is equal to 46.5. So in this case we get the lead angle lambda is equal to 2.74. Torque required to overcome the friction between the screw and the nut will be equal to W, that is F multiplied by tan of phi plus lambda multiplied by dm divided by 2. We have W is equal to 20 kilonewton, so we have 20 into tan of phi value is equal to 6.84, plus we have lambda is 2.74. Mean diameter dm is equal to 46.5 divided by 2. This answer will come in kilonewton mm. Multiplying by 1000, you will get this answer close to 157 into 10 to the power 3 will be Newton mm. F is known, Tr is known, so we can very well calculate the value of sigma c and tau. But before this, we will calculate the number of threads. To calculate the number of threads engaged, we have force F is same as equal to pi into core diameter DC multiplied by the number of threads engaged multiplied by pitch divided by 2 multiplied by the bearing pressure equal to sigma b. This time core diameter is 43 and number of threads we have to find out. Value of pitch is equal to 7 and the value of sigma b is equal to 12 and the value of load is equal to 20. So we have 20,000 equal to pi core diameter DC is equal to 43. Number of threads we have to find out into pitch, which is equal to 7 divided by 2 multiplied by bearing pressure, that equal to 12. Solve this, you will get the value of n 3.525 approximately equal to 4. The compressive stress produced will be sigma c will be taken as negative is 4f divided by pi dc square. So we have minus 4. F is equal to 20,000 divided by pi. This time we have to take the core diameter for a screw body, which is equal to 43, and you have to make a square of it. So this value of the compressive stress will come out to be minus 13.77. Unit will be megapascal. Similarly, we can calculate tau. Tau is equal to 16 times torque to raise the load without collar divided by pi into dc cube is equal to 16. Torque you have to take in Newton mm is 157 into 10 to the power 3 is divided by pi into dc cube is 43 cube is equal to 10.05 megapascal. So sigma c is acting along the y direction is equal to sigma y. We have tau xy is same as equal to tau, and the value of sigma x will be equal to 0. So we'll put this value and we'll calculate here sigma max and sigma minimum. So sigma x equal to 0 plus and minus. So we have minus 13.77 divided by 2 plus under root of sigma x is 0. Minus and minus become plus. So we have 13.77 divided by 2 whole square plus we have tau xy is 10.05 square of it. So one value we'll get as sigma max here, and we have maximum normal stress is equal to 5.3 megapascal, and the minimum principal stress on the screw body is equal to minus 19.06 megapascal. So these are the principal stresses acting on the screw body. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.